Alrighty, so in class today we debriefed from the lab. So remember, we started out by making sure we had all of our calculations on this front page all set, and we wanted to make sure we could look at the mole ratios with the acid being 1, and then also it's nice to see the mole ratios like I told you how to do it before, where they're all both whole numbers, right? Where you would just divide by the smaller one and you should have basically whole number ratios. Being able to see it in both ways was pretty useful. Pop back here. Of course I didn't get that. So then we went faux question, and we then made a more stylized graph, right? So this is showing kind of an ideal situation where you would see that we have our, 2 data points below our maximum amount, our 2 data points be above the point where we hit our maximum amount, and then we have our perfect point there. We saw that in general, the area down here at with increasing CO2 stayed acidic, and up here where it's flatlined, in general, it was more basic. And then we saw that that perfect point was potentially neutral, or we could see how maybe it should have been neutral. So when we were talking through this, we decided that if we were using the same exact amount of acid the whole time, and then we see in these first 2 data points, the red points, we see that we're getting an increased yield of CO2, well then the yield of CO2 is 100% dependent upon the amount of carbonate. So what we determined there is that the carbonate is determining our amount of product, therefore the reaction is being limited by the carbonate that we have. And by testing the pH after the reaction, we saw that the remaining solution was acidic for both of those points, which tells us that there was extra acid left over. So that constant amount of acid that we were using was more than the carbonate could react with for those first 2 points. In a perfect world, that third data point, the black point on my graph here, would show a neutral solution after the reaction and would represent that perfect amount, just the right amount of acid reacting with just the right amount of carbonate. Then we see with the flatline section, with the plateau of our graph, we're seeing that it's now basic, and that means that there must be carbonate remaining in that solution, leading to it having a basic pH. So we can see there that now we have excess CO3, 2 minus, excess carbonate, which is why it's basic, and we can then see that, gosh, we're not making any more, right? We're adding more and more and more carbonate, but it's not giving us any more CO2, so we must be being limited by the amount of acid we have. So these terms that we're looking at of excess reactant, limiting reactant, mole ratio, right? These are the big ideas that we're trying to get into with on here. Let me brief our data, and I'm going to look at this one because it just came out a little cleaner with 5th period stuff. So here are the 3 pictures. Oh no. There we go. Here are the 3 pictures of the bulk graphs that we did. You can see the color of the lab sheet up top. And again, remember we talked about that dipping in the data. So you can see with the yellow highlighter that each of these graphs, except the blue sheet, but each of the other graphs, they show this dipping right here, right? We see it here, we see it here. And remember, we talked about that. We're going to look at the details of that later when we get to equilibrium. But for now, I need you to trust me that the CO2 was produced. It just, some of it got dissolved in the water and so was not able to be collected. So what I want you to use is use your data, graph your data, but in your analysis, talk about the fact that this line, right, it does flatline. So from whatever that peak performance is, whatever that peak yield of CO2 is, you should be seeing a flat line across from there, okay? So then from there, we did some analysis of the graph in general. So after looking at our generalized data, kind of what we have here, let me just pop in. So if we come back here, we see with our, oh goodness, no, give or take-ish, sort of, sure. Right, so if we zoom in here, right, we could see that when we balance this acetic acid reaction, we get a 1-to-1 mole ratio for the acid to the carbonate. That would give us the stoichiometric molar ratio. It's like the recipe, right? If we want to make the sodium acetate, water, and CO2 using these reactants, we need 1 mole of each to get moles of the other ones, right? It's our recipe. Just like if you're making a sandwich or a cake or whatever, the recipe tells you the perfect amounts that you need to add to get the desired outcome. That's what our balanced equation tells us. It tells us those perfect amounts, those stoichiometric ratios. You can see from your graph that hopefully your perfect mole ratio should match these stoichiometric mole ratios that we got. For the HCl with sodium carbonate, it should have been 2:1, and for the citric acid, it's a 1:3. So you should be comparing those mole ratios to your experimental perfect mole ratios and seeing, are you in the right spot? Is that the data that you got? Because that's what the theory that you're going to be able to bring in is talking about that balanced chemical equation. Okay. An extra real quick picture of the up top part, because I want, sorry, this is going to make you seasick for just a second. I should have planned for this, but you know me. Okay, here we go. So if we look at the top part of your sheet, and I know you guys all have this, right? So here it is. Right, our guiding question, does mixing reactants in different mole ratios affect the amount of the product and the amount of each reactant that's left over? That's the question you're answering for your analysis, for your argument. So remember, claim, evidence, justification. Your claim is your answer to that question. Your evidence is whatever it is that you collected during the lab, any of this data processing that we did looking at the graphs in class today. That's where your evidence is coming from. And then your justification is where you're going to then tie that into the analysis that we did of our balanced reaction. And then over here, remember these ideas that we're looking at here. We're looking at the ideas of mole ratios, limiting reactants, and excess reactants. These are the things we're going to start talking about next class when we start digging into the math and to the real heart of stoichiometry. So that's what's coming next class. We're pretty much done talking about the lab. I need your peer edits turned in via Canvas. The assignment is here posted, and then you'll be doing your final draft over the weekend. So that's going to need to get done and get turned in. And remember, you're doing your argument and you're doing a graph. So make me a nice graph. It's all happening digitally. And then we're going to get into the details of stoichiometry. And then I think the beginning of next week, we're going to do our titration lab, and it's going to be fun. All right, I will see you guys soon. Good luck. Do well.